Okay, moving right along. In the previous chapter, we looked at the difference between private, public, and hybrid clouds. Now let's take a look at what they have in common: their architecture. Specifically, how data servers are built to serve thousands or even millions of users at the same time. Now, cloud architecture can be presented in a lot of different ways, but today I'm going to stick with a more basic description. We can think of cloud architecture as a building that's 3 stories tall. The bottom floor is the hardware layer. Above that is the virtual machine layer, and on top, we have what's called the scheduling layer. The building's foundation, the hardware layer, also known as the infrastructure layer, that's basically the data servers and the networks that connect them. This equipment can be located very close to the user. In the case of private clouds, the servers and networks are often located on-site in a server room or even in the basement. Alternatively, the servers can also be located very far away in cooler parts of the world or next to wind farms. I'll talk about why in a moment. Cloud servers vary widely in size, from just a few racks to many racks spread across multiple locations. The world's largest data centers tend to be in places with relatively low average temperatures. Servers and network equipment produce a lot of heat, so putting them in more mild climates costs less to keep everything cool. This is called heat dissipation, and it's super important in computing. Massive data centers also tend to be located in places with abundant renewable energy resources like hydro, solar, or wind power. Again, this is a cost issue. Huge data centers draw a lot of power, and renewable energy is both cheaper and better for the environment. Next is the virtual machine layer. To go back to the building metaphor, this is the second floor. Virtual machines are what allow cloud service providers to manage hardware from different locations in a unified way. Essentially, a virtual machine, or VM, lets you treat different pieces of hardware as one system. You can abstract, combine, and split computing resources any way that you want. This allows cloud service providers to deliver diversified, multi-level, and customized cloud computing services to users around the world. Now, virtualization is what makes cloud computing work. On the surface, these virtual machines are independent servers. They don't share data, they may use different operating systems, and when one VM crashes, it won't affect the other ones. Meanwhile, they also share resources like CPUs, memory, and network adapters from physical servers. A physical machine is usually called a host machine, and a VM is called a guest machine. So how do you virtualize physical resources? We use a hypervisor, sometimes also called a virtual machine monitor. It's a class of software that enables this. KVM, which is a free kernel-based Linux tool, is by far the most widely used open-source virtualization software in the world. KVM focuses on the virtualization of memory and CPU resources. Another software tool is needed to virtualize input and output resources like network cards and disk or flash storage. One of the most popular I/O device virtualization tools is called HUAWEI. In addition, the virtual machine layer includes another type of virtualization tool to interface with system admins. The most popular is called libvirt. Strictly speaking, within the virtual machine layer, only KVM itself is the hypervisor. But many people often lump together KVM, HUAWEI, libvirt, and Linux and refer to them collectively as the hypervisor. It can get confusing sometimes. On the top of this stack, the third layer of the building is the scheduling layer. The job of the scheduling layer is to marshal cloud resources. Scheduling identifies a host with spare resources among thousands of hosts within a particular cloud. It's called scheduling because one of its critical roles is to correctly schedule the order in which various cloud resources are used and tasks are performed. You can think of the scheduling layer as the cloud operating system. Laptops use operating systems like MS-DOS, Windows, Linux, or Mac OS. Mobile phones use Android, Harmony OS, or iOS to run their apps. Clouds also have their own operating system. The most common cloud OS is currently OpenStack. It's become the most popular cloud OS because it is open source, free, and it's maintained and used together by many small and large companies, so there's a lot of eyes and hands on it. OpenStack can work with a wide variety of software packages and cloud platforms. A cloud OS like OpenStack is a critical element in cloud performance. In the next lesson, we'll take a closer look at OpenStack and other cloud management tools.